All right, Bayes' formula. So this is if we're trying to find out probability of some BK given A is happening, I'm going to want to find out or write down all the different ways that all the different BKs could happen. So A given B1, A given B2, A given Bn, or whatever, however many of them. And then the numerator would be the one successful. So let's look at what this is saying. So here we've got two urns. We've got urn one, and let me just, organize it. At urn one, I have 7 balls, and there's 3 blue and 4 gray. And in urn two, I've got 8 balls, and there's 5 blue and 3 gray. And the probability of choosing either one of the urns is the same. Okay, so the denominator here, this big ugly denominator, is how many ways the event could happen, whether we choose from urn 1 or urn 2. So it's saying what's the probability if the chosen ball is blue. So that means urn 1 and blue, or urn 2 and blue, right? And what we're wanting to find is the probability, given that it's blue, right? Given that it's blue, that it came from urn 1. So the denominator is probability it is from urn 1 and blue, or the probability it comes from urn 2 and blue. And so you know that this translates to this, and then this one translates to this. And then this top here, is this also. So you recognize that 2 of them will be this one. The denominator will have one of the terms that's in the numerator. Okay, so let's go do this. And so this one right here, probability, given that it's urn 1, that it's blue. So going into urn 1, I have 7 balls in urn 1, and I will have 3 that I choose from. And then probability that it's urn 1 is 1/2. So that's the numerator. And so that this is the same. And then add on the probability that it came from urn 2, which is also 1/2. And this is that I chose a blue out of urn 2. So that's 5 out of the 8. So that's a fine answer just like that, right? All right, let's go to the next one. A little more challenging. We can do this. Okay, so I just tried to write out some kind of a, chart, so we get an idea of what the letters stand for, and I'd appreciate if you did something similar. Okay, so test positive, test negative. Negative has an A complement. Has the disease, doesn't have the disease, B2, right? So B1 has the disease, and so they tell us that there's 5 people in 1,000. So that's 0.005. And so what that means is who doesn't have the disease would be 0.995. All right, so let's talk about what a false negative means. False negative means that they test negative given that they have the disease. And so false negative, where'd it go? False negative, given that, here it is. False negative is 1%. So that's 0.01. Okay, so let's just right away do what I would, not the complement, but given that they test for the disease, or they have the disease, B1 has the disease and tests positive. That's what you want the test to do, right? So that'll be the complement of that. So that'll be 0.99. All right, so let's look at false positives. So false positive means that you don't have the disease, yet you test positive. So that's a 0.03. And so again, the complement of that was that you don't have the disease and you test negative, right? And that's what you want. You want this one to be very successful as well. So this would be 0.97. All right. Once we wade through all of that, so part A is asking us, what's the probability that a randomly chosen person who tests positive actually has the disease? So test positive, given that test positive actually has the disease, so that would be B1, has the disease given that they test positive. So that's going to be the probability of B1 and A over the probability that A is happening. And there's so many ways the probability of A is happening, right? So the numerator is probability of A given B1 times the probability of B1 all over, then I'm going to have to take into account the different ways that A is happening. So that could be A and B1, or, right, or actually I'll just do plus probability of A and B2. Oops, A and B2. Okay, so let's just expanding it out just a little more, just because. So this is the same as the numerator, right? So this is A given B1, probability of B1, all over probability of A and B1. Oops, A given B1, probability of A given B1 times the probability of B1, and then I've got the plus probability of A given B2 times the probability of B2. So let's fill in all the numbers. So probability of A, make it a little smaller so we can see all these things. Probability of A given B1, that's 0.99. And then I'm going to multiply that by the probability of B1, which is 0.005. All over probability of A given B1, that's 0.99 again. And then B1 is the 0.005. Remember, those two will be the same. So plus the other one, making the denominator larger, right? So it's a probability. So probability of B2 is 0.995. And the probability of A given B2, that's 0.03. Shoo. Okay, so let's do this last one here. I'm going to erase this so we can have some room to work. So last little bit. Probability that a randomly chosen person who tests negative. So tests negative is a complement, right? So given that they test negative, what's the probability that they do not have the disease? So that's B2. So that's like saying probability of A complement given B2 times the probability of B2. And then I can put the same things on the denominator, right? Here, given B2, probability of B2 plus probability of A complement not having the disease given B1 times the probability of B1. So that will give me a 0.97, 0.995, 0.01, 0.005, or a 0.97 and a 0.995.